Hi there, and welcome to Lambda U. My name is Darren, and I am a Solutions and Support Scientist at LICOR. In this section, we will discuss the science and best practices behind gel preparation for your Western blot. Once you have prepared your protein samples, it is time to run them on a gel. Complex protein mixtures can be separated by molecular weight using sodium dodecyl sulfate polyacrylamide gel electrophoresis, also known as SDS page. In contrast to dot or slot blots, where your protein samples are simply pipetted onto the membrane, SDS page provides you with the molecular weight of your targets. Estimating the molecular weight of your targets can be helpful in determining if you're actually detecting the correct proteins of interest. Most gel systems utilize a discontinuous buffer system developed over 50 years ago. This means that there are different buffers for the stacking gel, the resolving gel, and the running buffer. The most common system uses the Tris-glycine buffer system. Each component, including glycine, chloride ions, and the pH, are critical for the success of the gel run. At pH 6.8 in the stacking gel, glycine is uncharged. When voltage is applied, negatively charged chloride ions quickly move toward the positively charged anode. Uncharged glycine enters the gel but moves more slowly than the chloride ions. Protein samples migrate between the chloride ions and the glycine, slower than the chloride ions, but faster than the uncharged glycine. Moreover, the stacking gel has a lower concentration of acrylamide, so proteins migrate evenly at this point and stack at the border of the two gels. Protein separation begins when samples enter the resolving gel. In the resolving gel at pH 8.8, glycine becomes deprotonated and quickly migrates past the chloride ions, further stacking your proteins into a narrow band. Protein samples separate according to their molecular weight due to the higher concentration of acrylamide in the resolving gel. Smaller proteins travel quickly through the gel, while larger proteins are impeded by the acrylamide and migrate more slowly. Now that we know how SDS page works, we can learn about the different types of gels and how we can choose the right one depending on our targets. We'll talk more about that in the next lesson.